chain rule worksheet. Okay, the chain rule, of course, is if you have a function inside of a function, then the chain rule says you take the derivative of the inside times the derivative of the bigger picture with what was inside still inside. So the derivative of something like this would be the derivative of the inside, g of x, times the derivative of the bigger picture, f prime, with g of x, what was originally inside, still inside. Okay, and that's important. Keep the original in there. So we have this inside of the minus 2 power. So the derivative of the inside, so dy dx, the derivative of the inside will be 2x plus 9. Derivative of x squared is 2x. Derivative of 9x is 9. That's the derivative of the inside. Times the derivative of the bigger picture, something to the minus 2. The power rule says you take the minus 2 down and multiply it by everything that was there, the stuff that was before, inside before, plus 9x, to 1 less power. 1 less than minus 2 is negative 3. If we go to the next one, so we have 9 plus e to the 5x squared plus sine of 2x. And that's all to the 1/3 power. So we have all of this is the inside, the g of x. And inside there's a sum, and inside that, there's some chain rule stuff going on also. So, dy dx would look like the derivative of the inside. The derivative of 9 is 0. The derivative of e to something, you have to do the inside again, like we said here, derivative of the inside. So the derivative of 5x squared, that's poorly written, but is 10x times the derivative of the bigger picture, e to something, is still e to the same something. And then we have plus, this is the sum rule, so I'm going through it. We have something inside of the sign. So the derivative of the inside is, derivative of 2x is 2 times the derivative of the sign, the bigger picture, is cosine of what was inside, 2x. So there is the derivative of the inside, and now we've got to take it times the derivative of the bigger picture, all of this to the 1/3, which becomes 1/3 of all of that, all the original stuff, the 9 plus e to the 5x squared plus sine of 2x inside of that, to the 1 less than 1/3, which is negative 2/3. Okay, this one. All right, so we have the tangent function, and inside that we have a product. So when we go to do the derivative of the inside, we're going to have to do a product rule. So it's derivative of the first times the second plus the derivative of the second, and inside that we've got 3x, so the derivative of the inside is 3 times the derivative of cosine is sine 3x times the first. So all of that is the derivative of what's inside the tangent. Now the derivative of the tangent is secant squared of what was inside it. What was inside it was all this, so it's secant squared of sine of x times cosine of 3x. So that's dy dx. Derivative of the inside times the derivative of the bigger picture of the inside. Number 4. We have the insides and we have the secant of the insides. So dy dx will be the derivative of the inside, which is a quotient rule, that will give us the derivative of the excuse me, inside times the derivative of secant with this stuff inside it. Let's start with that. The derivative of secant is secant of the stuff inside tangent of the stuff inside. Well, the stuff inside is 3x squared over x plus 2, and the tangent of the stuff inside, 3x squared over x plus 2. There's the derivative of the bigger picture with the stuff inside kept inside. I'll move that there and get that up there. And this is times. But we still have to do the derivative of the inside, which is the derivative of the numerator times the denominator. It's got a sum, so I'm putting parentheses. And then the derivative of the denominator, derivative of x plus 2 is just 1, times the numerator over the denominator squared. Okay, that's the front side of this sheet. Now the back side. I asked you to graph this. So I'm going to pull out a ruler to help me here. Oops, sorry, bump that. I'm going to make a line down the middle. I don't know if you can see that any darker. I'll put arrows on it. And I'm going to go horizontally here. That's the X, and this is the Y, arrow, and arrow. And I said make the grid go 2/10 by 2/10. 2, 4, 6, 8, 1. 2, 4, 6, 8, 2. Minus 2, 4, 6, 8, minus 1. Minus 2, 4, 6, 8, minus 2. 2, 4, 6, 8, 1. 2, 4, 6, 8, 2. Minus 1 and minus 2. F of x. At minus 2, it's minus 4.42. Then it's minus 0.23 minus 0.3, 1.7, 3.6, 0.54, 0.4, 0.54, 0.7, 7, 0.83, 0.92, 0.98, 1, 0.98, 0.92, 0.83, 0.7, 0.54, 0.36, 0.17, 0.17, negative 0.3, 0.17 here, negative 0.3, negative 0.23, negative 0.42. Okay? G, negative 2, 8 off the graph. The first one will be on will be 2.2 negative at negative 1.424 will be at negative 2, negative 1, negative 2.24674. Negative 1.2, we're at negative 1.6, 1.73. At negative 1, we're at negative 1. At negative 0.8, we're at negative 5.1. Negative 2.2. Negative 0.6. Negative 0.1. 0, 0.1. 0.6. 2 at 6 is 2.2. 0.8 is 0.51. And at 1 it's 1. And 1, 2, 4, 6, 7, 3. And 1.4 it's 2.24674, somewhere from there. Okay, so this is f of x, and this is g of x. Now it says t of x equals f of g of x. So to find t prime at 0.6, let's find t prime, which is derivative of the inside, g prime of x, times the derivative of the bigger picture, f prime of g of x. So we need to know g prime at negative 0.06, negative 0.6, excuse me, 0.6. So the slope of g prime at negative 0.2, 0.4, 0.6, the slope there looks like it's about 1. So it looks like about 1. And g of negative 0.6 is negative 0.22. So the g part is negative 0.22, and we're supposed to find f prime at that. Well, at negative 2, f prime at negative 0.2, f prime is there, which is a slope of about oh, I don't know, 1/4. So that looks like it's about 0.25. Now, we could do these not with the drawing tangent lines, but using central difference. So at negative -0.6, the slope of g would be this minus that, negative 0.06 minus negative 0.51 over negative 0.4 minus negative 0.8, which works out to be and we got negative 0.06 minus negative 0.51 in the numerator divided by negative 0.4 minus negative 0.8 plus parenthesis, and we get, oops, I've got something typed wrong. If I push 2, it'll tell me what I did wrong. Oh, I forgot to start my denominator parenthesis. Second, insert a parenthesis. Enter. I get 1.125. That's the slope of g prime at negative 0.6. I got to take that times the slope at negative 0.22 for f prime. That's close to there. So I'm going to do f, so I'll do 1 minus 0.92 over doing 0 minus negative 0.4, which is going to be 1 minus 0.92 is 0.08 divided by, and this is 0.4, and I get 0.2. So I got to take this g prime times f prime at negative 0.22, which is 2. We estimated it to be 1/4. This says 0.2, 0.25. This we estimated at 1. It was 1.1. We get 0.2 times 1.125, and we get 0.225 using the central difference, using eyeball on the graph. So we got somewhere in there, about 0.23, 0.24. Okay, both of them are estimates. Now, I ask you to do something a little bit trickier here. We get r of x, which is f of g of x over f of x. So that's a quotient. So r prime of x will be the derivative of that, which we just figured out. But it's going to be a quotient rule. So let's go. So we just figured this one out. I'll use the central difference one, or something close to 0.23, the derivative of the numerator times the denominator, f of negative 0.6. That's 0.83. Minus f prime at negative 0.6. Okay, we haven't done that yet, so f prime at negative 0.6. So we've got to do 0.92 minus 0.7. Over negative 0.4 to minus negative 0.8. Negative 0.4 minus negative 0.8. So that becomes plus, and 0.92 minus that is 0.22 over, that would be 0.4, and that turns out to be 0.22 divided by 0.4, 0.55, or a half. Let's take a look at here. At negative 0.6, the slope of the tangent line, yeah, I can see that it's about a half, going up 1 for 2. Okay? So we could have estimated that slope times the numerator. So we got to put into G negative 0.6, which we know is negative 0.2, and then we're supposed to find f of that. So negative 0.2 f is 0.98 over f of negative 0.6, and f of negative 0.6 was 0.83. We have it here. So 0.83. So now we got to work that out. I'll do the math, the fraction thing that I can do on the calculator. So I got 0.23 times 0.83 minus 0.55 times 0.98. And in the denominator, I have 0.83 squared. And I get negative 0.51-ish. Okay? Now it says, what I did is I made this table up with the cosine and the x cubed. This is the x cubed graph, and this is part of the cosine curve. We go down and come back up. We've got the cosine curve and the x cubed graph. And so now I want you to take a look at this just using the calculus methods we have. So the first one was f of g of x. G of x inside the f. F is cosine of something, and put the x, g of x in it, so that would be f of x, f of x would be cosine of x to the third. So if I took the derivative of this, I take the derivative of inside, that's g prime, like we did up here, derivative of the inside. This would be not f, but t of x. T of x is this. So we take the derivative of the inside, which is 3x squared times the cosine of what was originally in there, x cubed. So now, if we find t prime of negative 0.6, and here some people had trouble with this because they weren't following order. When you deal with a negative inside a square or inside a cube, you got to be really careful. You got to put that negative in parentheses also. So this is 3 parentheses negative 0.6, that whole quantity squared, times the cosine of, now we want to, this is inside the cosine, but inside the cosine we have a, inside the negative 0.6, that negative 0.6 is to the third, the negative and the 0.6. If you don't put parentheses around the negative and the 0.6, it'll only cube the 0.6, and then close the cosine. And we get 1.05. Now, how does that compare to what we had before? Let's see here. Oop, what did I do wrong here? T prime of negative point. 3 times negative 0.6 squared. Negative 0.6 squared. Oh, I didn't do the derivative cosine, which is sine. I didn't do the derivative of cosine. Come back here, go back and change that cosine to sine. Forgot to do the derivative of that part. Okay, press enter. Now I get negative 0.23. Negative 0.23. That matches what we had before, negative 0.22 to negative 0.25, negative 0.23. So I took the derivative of the inside times the derivative of the bigger picture, which I didn't do the derivative of, with the same stuff inside. I was focused on the inside and forgot to take the derivative there. Hopefully you guys won't make mistakes like that on your test. Okay, and now we have to do what we just had. F of g of x, that's t. That was cosine x to the third over f of x, and f of x was the cosine of x. So that's what r is. Now if I take the derivative of that, it's a quotient rule. So r prime of x will be derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. The denominator squared. Derivative of the numerator times the denominator. Derivative of the denominator times the numerator. Now, derivative of the denominator is sine x, and the derivative of the numerator we just did, it's, and I messed it up, but it's 3x squared sine of x to the third. Now, if we have to put in negative 0.6 into this, r prime, it's probably going to be easier if we just type this into, we know what this one is. We just got it. But I'm going to go show you that instead of worrying about all the parentheses on the negative 0.6, if we just type this into the y1, clear that, and type in the numerator, so math, fractions, and do the numerator, 3x squared sine x to the third, close that, cosine x, close that, I've got that part of the numerator, minus sine x, close that, cosine x to the third, come down, close that, there's my numerator. Now I don't have to worry about me putting in that negative 0.6 correctly, and down here I got to do cosine of x, close it, and that whole thing squared. So now I've got it typed in the calculator into y1, and I can either go to the table and ask what is it at negative 0.6, or I can quit and go to y bars and say y1 parenthesis of negative 0.6. In either case, I get 0.53. before I had negative, and this time I don't get negative. What? What am I doing wrong? What did I get on the table? I got positive. Here I got negative. Did I do something wrong here? I think it is negative. What did I do wrong here? Oh, I'm doing derivatives of cosines. Oh man, sorry I'm messing you guys up on this. The derivative of cosine is negative sine. That's not a derivative. And the derivative of the cosine here is negative sine. So that changes the signs of that, which will change this to a negative. So now that matches what we had before. Negative 0.53. Got to be careful about the negatives on the derivative of cosine. Okay? Sorry, I make mistakes in there. Okay? Find them though.